Alright, so we're going to graph this rational function right here. Starting with your VA vertical asymptote, we set your denominator x minus 2 equals to 0. Solve for x by adding 2 to both sides, so we have x equals 2 is our vertical asymptote. I can go ahead and draw that line in. Here's my x equals 2. Alright, now the EBA, this is where you take your leading term, x squared from the numerator, over the leading term from the denominator. Compare the degrees. If the degree in the numerator is bigger than the degree in the denominator, then we're going to do synthetic substitution. So our synthetic substitution, we take the coefficients from the numerator, so you have a 1 in front of your x squared, and you do need the other terms. You need x to the first power and x to the 0 power. That's a 0. Because you do not have those terms, there must have been zeros in front, so we're going to kind of fill in our places with zeros right there. And then we're dividing by an x minus 2, so tricky x, we're going to put a positive 2 right here. So when we do our synthetic, we bring our first coefficient down, 1, multiply it times the 2, and it's going to go right there. Then we add down, 0 plus 2 is 2. Multiply that by the 2 on the outside and we get 4, and bring that down for a 4. So here's where that last number that we just came up with, we never used that, and because we took an x squared divided by an x, we're left with an x to the first power, which will go with that first number. So our EBA will be y equals x to the first power plus that 2. That basically becomes your line right there. So x plus 2, if you go up 2 on your y-axis, and then you're going to have, let me see, oh, good, it'll let me do that. Then you will have a slope of 1, so up 1 over 1, and we can draw in our slanted EBA like that. Alright, so continuing on, we have our x-intercept. To find an x-intercept, you will plug in 0 for y, so we'll have 0 equals x squared over x minus 2. And remember, if you make that 0 over 1, you can cross multiply. 0 times x minus 2 is 0, equals 1 times x squared is x squared. If you solve that for x, you're going to get a 0 for x, so you write your intercept as 0, 0. Your y-intercept, let's plug in a 0 for x, so we'll have y equals 0 squared over 0 minus 2. 0 divided by anything is 0, so your y-intercept is a 0, 0 also. You plugged in a 0 for x and got back a 0 for y. So when we do our table of values, we center this around your vertical asymptote. You want the 2 numbers on the left side and the 2 numbers on the right side. Because our VA is at 2, I'm going to use 0 and 1. Those are on the left side of 2. And then I'm going to skip the 2 and do a 3 and a 4. Now I already plugged in a 0 for x for the y-intercept. And I know I got a 0 back, so I know that point will be at 0, 0. Now we plug in a 1, and now we're just going to do a little bit of math. If you plug in a 1, I wonder if I can... Oh, there's a little space over there. Alright, you have 1 squared over 1 minus 2, which is 1 over a negative 1, so a negative 1. Plug in a 3 squared over 3 minus 2, so 9 over 1, that becomes a 9. 4 squared over 4 minus 2, so 16 over 2, which is 8. Alright, so we can go ahead and plot those points. Maybe I'll use red's a good color. 0, 0 is going to go right there. 1, negative 1. And then I go over to 3, I go up 9. Now this will be off my graph, so I'll just 7, 8, 9. It's right around here. And then over 4 and up 8, which will be approximately there. So this curve definitely is off of my graph, but we'll be able to draw this in. So remember, your curves have to fit within your without crossing your asymptote. So the first one will look like that, and then the second one will look like this, because remember we have that one asymptote going straight up, so we know that it's just going to end up going right next to that. So there is our graph. And what's going to be, on one like this, remember it's that having to do the synthetic substitution for your end behavior asymptote.